Total solutions for any mix, any volume. All managed by Panasim Enterprise Edition. Panasonic. Total solutions beyond SMT.
Welcome to the Kurtz Ersa booth here at SMT Nuremberg. I'm joined by Tobias van Rosen. Welcome, Tobias.
Thank you, Trevor.
Now, when we spoke to Ersa at Apex a couple of months ago, we were looking at one of your reflow ovens, which has got a fairly unique void reduction system. There's a number of different ways of reducing voids, but you've taken a sort of piezo method of using a frequency to delete them. You've transferred that now to a rework system that's behind us, so can you tell us a little bit about how this works?
Absolutely, you're right, Trevor. So as you know from the Apex show, and we also presented at the Proelectronica already, we developed a way with a piezo element to reduce voiding dramatically in the reflow process. This is a system which is very good for an inline process in a reflow oven because you don't need so much time. We only need about 10 seconds takt time for one board to reduce voiding by about 88 to 90%. And like you said, what we realize is that this is very easily implemented into the rework process as well. If we look on the market, other systems, what is also working on void reduction can be implemented, let's say, in a big machine, but to do this into the rework, actually only our method is the only one which is really fit for that.
Now, when it comes to rework, though, there is actually a greater instance of creating voids because it's got some manual involvement.
Yeah, exactly. I mean, a reflow process, or let's say an SMT production line, is a line where you try to control the processes really in detail. You can control your printing process in detail, you can adopt it, you can have your pick and place, or a high quality pick and place, you do not have problems over there. Your reflow process, you can really have influence on every little small parameter. In rework process, this is a little bit different. Of course, you try to control as much as you can, but it's an open process. And the board itself, where has the board been? Maybe the board was in the field for some time. Are your components really in a dry storage? The printing process itself is done by hand in the rework process. So there's much more variables which can create voiding, which give you much bigger voids. So basically, voiding is a much bigger problem in rework than in, let's say, a reflow.
So let's talk about the actual process itself. I mean, some people would say, well, are you shaking the board? I mean, how does it work?
Well, that's what they like to say, of course, but we're not moving the board at all. That's a very important thing. We have our marketing term is our sinusoidal sweep. What we do is basically we move in between what people know as ultrasonic and sound. And that's also why you hear very well the sinus sweep when we apply it to the board. I always compare this, or it's not the same thing, but it's very similar to everybody knows from the comic books, where the opera singer is singing very highly, and then the glass on the table is breaking, is exploding. Nobody's shaking the table as well. And it's an analogy to what we do over here. So we're not shaking anything, but with our sinusoidal sweep, we move out the air, let's say, or the voids inside of the solder joint without moving the board.
So the system that we're seeing behind us, Tobias, is the Rework 600, which is a system you've had in the field already, but you can actually retrofit it with this void reduction system.
Exactly, that's really the beauty of it. This is not possible in our reflow oven because there's much more structure around it, but in our rework processes, the machines in the field can really be upgraded with this system very easily. It's just an upgrade kit. You slide the rework system inside the table, which applies a sinus sweep, and ready. So it's an upgrade which takes half an hour.
Okay, so what else have we got that's new this week on the booth?
Well, especially on the selective process, we have added a few things to our existing machines, to our existing technology. We have implemented some more process control features.
Let's go over and take a look at them.
Okay.
So Tobias, here we are now in front of the VersaFlow system. This is your selective soldering system, and we've got a couple of additions at the front and the back end. Can you tell our viewers a little bit about what you've done here?
Well, Trevor, what we see in selective soldering lines is that the placement of the components is done by hand in 99% of the cases. Some customers have automatic placement systems, but a lot of THT components are very difficult to place, and this is still a human job, a manual job to do. And we know where the hands come in, the mistakes can come in as well. So therefore we created in front of the machine our Versa Scan module. First of all, this module can scan up to 10 different barcodes on a multi-panel.
Okay.
Also, we can check for bad board marks. Bad board marks meaning, like you know from your SMT line, this board then will be skipped in soldering. But moreover, and what we just talked about, started talking about, is that if there's errors, meaning wrong polarity, missing components. You know, on a Monday morning feeling, the operator forgets or is talking about his weekend to his colleague, the machine will detect this, and in this way we will not create the error, but prevent it from happening. So this board or this particular component will not be soldered then.
Okay, so it actually communicates further up the line, and the heads actually don't solder the component, so basically you're not into costly rework.
Yeah, exactly. It's fully integrated into our machine. As you can see here as well, it's one machine, it's one communication system, so yes.
So the unit at this end is called the Versa Scan, the unit at the far end is called the Versa Eye.
Yeah.
So I'm assuming that the Versa Eye is really confirming that it's soldered correctly, has it?
Exactly. In the Versa Eye, we control the quality of the soldering of the machine. In the Versa Scan, of course, the camera, as you can see over here, is from the top side, checking all the components. Then after the soldering process, we will check if all the solder joints are okay, if there's any shorts. Basically, it's, like we said, it's a quality control system.
Right. So that's obviously looking from the underside then at the terminations underneath the board.
Exactly, exactly. So no need of flipping the board or anything. Again, integrated into the machine, one platform, and immediately we inspect from the bottom side, standard-wise with one camera, optionally with 9 cameras to have a full quality control.
Okay. Well, that's a couple of really cool innovations this week. Tobias, I want to thank you for joining us and telling us about the latest stuff here at Kurtz Ersa.
Thank you too, Trevor.